Hello, everyone, and welcome to the Tom's Hardware Podcast for June 8th already, 2021. As always, I'm Tom's Hardware Editor-in-Chief, Avram Pelch, and I'm joined by Associate Editor Les Pounder, Raspberry Pi expert Ash Puckett, and our very special guest, Pascal Wistinhausen. Did I pronounce that correctly?
Yeah, perfect.
Wistinhausen of PKElectronics, who has made some really cool stuff, including a 3D printer control board powered by Pi that he's going to show folks today. So, Pascal, how long have you been doing Pi projects, and is this the first one that you've made?
So, yeah, I actually had to look this up in advance. So I got into Raspberry Pi right from the start. I had to look up the exact date, but I got this email on May 2012 about being able to pre-order a Raspberry Pi 1 right now. And I actually had to forward this to my mother because I had no access to a credit card. So she purchased my first Raspberry Pi for me. And yeah, from this time, did a lot of interesting projects with it. Although the initial Raspberry Pi 1 I got is not longer with me. I think it went in some project for a friend. I actually can't recall where it went. And so this is how I got into this, and I basically followed the development of the Raspberry Pi throughout the years. In fact, I'm a embedded systems engineer, so I'm working with hardware designs for kind of some time right now, and it's definitely not my first hardware project, but it's the most the one that got the most attention so far.
So what can you tell us about this controller board? Do you have one to show us? What does it do?
Sure. So I brought one with me, and of course I can show you. But what I did is I put together all the things that you currently find in the state-of-the-art 3D printer control boards and 3D printer control in general, and put it together on a single board. So you can see it here, the Raspberry Pi Compute Module 4. Based in the center, we got some power electronics here to drive like the heated bed or the extruder heaters for the 3D printer. We got lots of stepper motor drivers on the one side for movement of all those axes of the 3D printer, and basically a good set of peripherals for fans, for temperature sensors, and of course the obvious parts here like USB, Ethernet, and HDMI. And what is interesting here is a really common setup for those control boards is to have a Raspberry Pi and a second board with an STM32 microcontroller, for example, to drive the real-time the real-time hardware part like stepper motors and so on, and put the user interface and sometimes even the motion planning on the Raspberry Pi because of its superior computing power. And I had this idea to combine both functionalities on one board, actually like 2 or 3 years back. But I even looked into the Compute Module 3, but this was not really the stuff that I wanted to do, so I postponed the project one time after the other. A few months back, there was this thing from ST Microelectronics, which actually combined 2 1 gigahertz ARM cores and a microcontroller into a single chip. So I looked into this as well, but it really didn't cut it. And when last year in October the CM4 was released, I sat there and said, yeah, this is it. I want to work with it, and let's go build this thing.
The technology was there.
Yeah, absolutely. And I finally had this vision in mind and said, yeah, I can make this happen based on the CM4. And yeah, I did it. And now it's here. And when I first started releasing renders and posting on about it on social media, there was a huge huge feedback from the community saying, hey, this is cool, shut up and take my money. And after this happened to be not only a single person but a few more, I then decided that I'm going to make a crowdfunding campaign for it, and we'll be going live if everything works out on the 1st of July. So yeah, then we can see if people want it, we'll make it happen.
So, how many printers can you control with this? You said 4. Is that the maximum?
So this it's actually one unit per printer, and
1 unit per printer.
and
Did you say there was 4 fans?
so there, I think so. So it's kind of flexible. So you can, for example, when we talk about 4, we have 4 channels for temperature sensors, which can be distributed to the different functions of the printer. Some might go for a multiple extruder setup. Some may want to go for additional sensors in a heated chamber, for example. And yeah, it's freely configurable. You get a good subset of peripherals to use there, so you can build sophisticated printers with it, like even bigger setups like the Voron 2, which actually use 4 motors for the Z-axis, which is kind of a challenge if you go for currently available 3D printer boards, which is actually the reason why they always use 2 standard boards from the well-known suppliers to drive all those stepper motors. And on my board, you have 7 stepper drivers, which is actually perfectly enough for Voron 2, which comes somehow because I want to build one for myself, but haven't really found the time to do this yet. So when I started designing this board, I talked to a good friend from the Voron community and asked him actually about what do I need to include to get this going for Voron 2, and he said, yeah, go for at least 7 stepper drivers, and so I did. And yeah, we'll see. I got a bunch of prototypes at hand, so once I start building one of those printers, I'll be ready.
So you haven't had the opportunity yet to actually stick it inside of a printer design of your own? That's coming next?
I don't think so. I think I'm not the mechanical engineer here, so I do some stuff in Fusion 360 from Autodesk, but not really because I love to do it. It's more like, yeah, I use it when I have to, but I'm not that good at it. So, yeah, I'm
What
good
did you
at
design
designing electronics, but
Well, the
I
board.
won't.
What did you design the board with?
That's actually done completely in Fusion 360. So after they acquired former company which produced Eagle, the layout software, and they integrated all those PCB design functions into Fusion 360, and so it's yeah, in fact it's even some kind of education project for me, because it's the first one I did completely in Fusion 360. They had a migration phase where you could push the designs from Eagle to Fusion and back to do some renderings or mechanical stuff in there. But at this time, I started completely from scratch in Fusion 360 and build it there.
So
I'm actually really satisfied with it. It works. By now, it works pretty well. It had, I'd say, a rough start with some features not performing as you were used to when you take the step from Eagle to Fusion, but most stuff got fixed right now.
So what hardware would you use this with?
So, what do you mean?
I mean, like, what printer would you use it with? Would you use to design your own printer, or would you use it with some of the existing models?
So yeah, in this case, I used it in an existing printer. When I bought it, it was a common Chinese brand like Tronxy. I don't know if somebody knows it. And I modified it over the time. So the aluminum profiles of the printer are still the original ones, but most other things have been replaced. And a few weeks back, after I got the first prototype working, I even replaced the old board on the printer with one of mine. And by now it got over 100 hours of printing time. So it didn't burn up at first time turning the power on. So that made me really happy.
That's always a good sign.
Yeah, absolutely.
Yeah, that's always good to get it working. So we have to ask you the question we ask all of our guests, except for Eben Upton, who probably has too many. How many Raspberry Pis do you have?
So at the moment, I got like 7 ones installed somewhere. Of course, one per printer. So yeah, but I think I didn't count in the 2 compute modules that arrived today in the morning. But I worked with far more Raspberry Pis over the last years. I worked sometime for a company which actually did a commercial project around a Raspberry Pi 2B, and we even got those production packages of Raspberry Pi boxes, which is like a box 40 centimeters squared with like 200 Raspberry Pis in it. That was pretty cool.
Yeah.
And of course, I didn't own them. They were for a customer, but it was
Still satisfying to open.
Experience, yeah.
I have a question. You mentioned earlier that you had the project idea when the compute module 3 was standard, and when the CM4 came out, that something about it was different. What specification wise about the CM4 set it apart from the 3 that made it a better option for this controller board?
So in this case, it was all about the form factor and the connectors, because on the CM3 you had this whole lot of GPIO, which in this case sits around unused, like 90% of it. We use a UART to communicate with the STM32 microcontroller, and that's basically it. There are some more convenience functions I added because I thought I just can't use just for GPIOs, and this is basically the reason why I didn't want to go for the CM3, because it had so many GPIOs there and took a lot of space, which would be more or less useless in this application. And with the CM4, it actually it got smaller overall footprint, and even with the this small board-to-board connectors, I saw it and I thought, this can be a beautiful solution. And
Pascal, are you using the onboard eMMC flash on the CM4?
No, actually, I still stick to an micro SD card in here, because especially in this prototyping phase I'm in here, it's far more convenient to just so I can just unplug the SD card, I flash a different image and try again. And this is something that, especially once you mounted it in the printer, this gets pretty hard
That's fair enough.
to work on it. But there's no reason, no technical reason in this case why you should not be able to swap the CM4 with one that has an eMMC on board.
Great.
Cool. Could you flash the MMC directly from the board? Or would you have to flash it on another board and then drop it into your board?
Yeah, this would be possible, of course, but you could also just flash it on board. I added a connector for the USB connection you need for flashing, and yeah, of course it's possible. I just took the easy way, one could say.
Don't blame you.
The True Linky asks, I guess we have a 3D printer board, a 4K HDMI port. Is SLA printer in planning?
So, from my side, I'm not that much into SLA printing, but I've been approached by a open source printer development group who actually wants to do this, and they asked me to join their team to make this happen. And yeah, in this case, we are talking about using both HDMI ports with 4K resolution for a masked SLA printer.
So I understand you have some other projects that you're working on. What are some of the other things that you're working on in the background?
Yeah, so I can switch to this. This again, what's a bit older actually is this small hat we did here. It has a rather limited functionality, but it actually solves a problem for firefighters and their alarm system, because usually, at least here in Germany, you have this some kind of pages given to them, which work by a completely separated RF system, which is independent of like GSM or something like else. And in addition, there are some systems to alarm the firefighters or emergency personnel using an app-based approach. And what we did here is, it's actually not my invention. It's I did it with a fellow firefighter. We did a board to connect both systems together. So at this screw terminals, you can have to find the right spot for the camera. So at the screw terminals, you connect like the base station of one of those pages, and once you get a message on it, it forwards this state change of the alarm to the app, and so you can reach even people which work like in a deep basement. Maybe they have Wi-Fi access for them, but this custom RF system doesn't work. So it's like a second level of security to really notify them of like a fire or another emergency. And throughout the time, let's put it other way. This is something we are currently working on as well. This has been in the prototyping phase for like half a year now, because we really want to be sure that it works all the time. It's built around some few lines of Python code and REST API for a web server. And in this case, we really want to make sure that it works all the time. And I even made a small Raspberry Pi project out of this this appearance in your PiCast, because what you can see here, what we are streaming, is actually recorded by a Raspberry Pi HQ camera and streamed over a Raspberry Pi 4. And let me just turn the camera a bit so I can show this. It's just, yeah, I needed to find a solution to do it the way I like, with the with some small multi-camera setup. And yeah, I mounted the HQ camera on a tripod, connected it to a Raspberry Pi 4, and now I'm currently streaming all of this via network to my laptop to then push it to this live streaming service here. So
Great. See,
Cool.
there's so much you can do with this. So speaking of so much you can do, I know, Les, you have a project that you've been working on, correct?
I do indeed, yes. It's a personal project this time. So I recently got a new keyboard, and it's one of these small plank keyboards that has 62 keys. And it was a cheap AliExpress purchase. I thought, I'd see what it's like. It works really well. It's got red switches, a Kale, possibly a copy, I'm guessing a copy switch. Works really well, but I have a problem in that to use certain keys, which I'm a Linux user day in, day out, so I use the up and down arrow to search through my command history in the terminal. To use that, I have to turn off the functionality of using the / and question mark, that sort of thing, that key. It's all shared, and it's a bit of a pain having to do it all the time. Likewise, I use page up, page down to navigate web pages quickly, and print screen is my friend for getting screenshots to put up in articles. And I thought, well, I need to make something to get this done, because this keyboard, while it's great, it doesn't work very well for me for doing those jobs. So I thought, let's build something. Well, me being me, I had a camera that has now crashed. Well done. Hey, there you go. Going back to the old school way like I did the other week. Okay. I've got a Gamecube 2040 in my hand. And this is... Oh, my phone's completely crashed. That's great. This is my spare keyboard. This has hotkeys on for different applications. Now, this is geared for Linux because I use that all the time. But I have set up some keys to use for the show tonight for OBS. So I'm going to just go into OBS now. And if I press the second key, it should have gone to my overhead camera, which was my phone, which is now crashed. And if I press the third one, it goes to the code which controls this project. And I'm just pressing these keys. I'll try and keep it in shot so you can see what I'm doing. There you go. Camera 1, camera 2, camera 1, camera 2. There we go. And I just thought it'd be really handy for you to have this for OBS for the show, and also for general hotkeys when I'm working and doing different tasks. So I'm going to show you quickly how the code works. Hopefully this won't break. So let's go to camera 3. And you can see the code in Microsoft Visual Studio Code. I'm not going to go through it all. There is quite a lot. There's a lot of repetitions as well. So I'm going to do just a really fast look through the code. So the first 9 lines are simple imports to make sure that I've got all the functionality to make this keyboard work. So there's a special library on line 2, Gamecube 2040. This is Pimoroni's own library. And it has an abstracted functionality. So I don't have to worry about the lower level commands to make things work. I can just say key 0 has been pressed, do this, or turn this LED on. And there are LEDs on here. There are Neopixel LEDs. I've got USB HUD interface, and I've got a US keyboard setup. And I'm dabbling with consumer controls after someone mentioned the other day about using stuff like this with mobile phones and the volume keys, which I thought would be quite interesting. Lines 12 to 14 just are objects that say, I'm using I2C for connection. My keyboard has an I2C address, and I'm using, from the keyboard library, the keys object. Then I'm going to skip past all this when I go to line 25. So line 25, keyboard set all 000, is an instruction right at the start that says, turn all the LEDs off. No lights whatsoever. And then I have 16 conditional tests. So while true, so the loop's constantly going around, There are 16 keys on the keyboard, and there are 16 conditional tests. So key 0, the very first bottom left key, which is that one there, will actually go to screen 1, so camera 1. So if I press that now, you'll see it goes back to a big picture of me, big scary picture. Let's go back to the little one. And I just say, okay, send this key code, Shift and A. And in OBS, I've set up Shift and A to mean go to scene 1, the main scene of me. Then I say, if the button has not been pressed, so the toggle button never been pressed, it's false. Set that value to true, and then set the lights to red. So set key 0's light to red. So you'll see it's 02550. These LEDs use GRB format for the lights. So green, red, blue, rather than RGB. Yes, that sounds really weird. There are loads of lights out there that do that. And it did confuse me for a good 15 minutes, so I thought I'd done something wrong. Then I have another little conditional test in here that just says, if it's true, make it false, and then set the lights to 0. And that should toggle the LED of key 0 to turn on and off. There's a little bug there, I'm still working on it. But all I'm really doing when I'm pressing a key is just checking, has that key been pressed? Yes. Okay, make the lights, all the light in this case, green. Then send this keyboard command. So key code control, so the control key, and then the down arrow, which on my Linux setup controls the volume. And then just a few pauses here and there, just keep things nice and tidy so we're not going to get key debouncing problems where the keys accidentally pressed twice. And it just repeats ad infinitum all the way down with different key combinations for controlling page up, page down, end key, the volume keys. I've also got a special key here for, so number 13, unlucky for some, Control-Alt-T, which in Linux opens a terminal, and I'm constantly in a terminal, so I'm just opening terminals left, right, and center with that key. And yeah, this is a problem. This is a project to scratch an itch that I've had, and so far it's going all right, apart from my phone crashing.
That's awesome. I love that it's integrated with OBS.
Thank you very much. That was one of the goals because we do a lot of I do a lot of switching of cameras on the show, especially when they break. So I thought it'd be really handy. Plus all the bits and pieces that are missing, well, not missing from the keyboard, but hidden by the really complicated way of pressing Shift and Function for 2 seconds to then change the key map so I can use the up arrow. It's like, okay. Now I know why this keyboard was $30.
Yeah, no question. So Ash, you have been playing around with something too, right?
Yes.
Gamecube.
Yes, emphasis on playing. So the Raspberry Pi is well known as a retro gaming emulation device through applications like RetroPie, which we have guides on Tom's Hardware. However, my favorite console is the Nintendo GameCube. And that is a really difficult console to emulate, let alone on something small like a Raspberry Pi. But if you've got that itch, I found a way to scratch it. I have found a way to play GameCube games with a Raspberry Pi. Not on the Raspberry Pi, but still with the Raspberry Pi. So if you're using a Raspberry Pi as a media center or it's hooked up to your TV, this is going to get GameCube games back in your life on the big screen. Well, the bigger screen, not just your computer. So let me switch my camera here really quick. So the big trick that I found to get this to work is through Steam Link. You will need a Raspberry Pi to get this to work. I'm using a Raspad to get this to work, which uses a Raspberry Pi 4. But you can use a Raspberry Pi 3B Plus with Steam Link, which is a benefit. That opens this project up to more people, I think. But you'll also need a computer with Dolphin installed. Dolphin is a free open source GameCube emulator that also emulates Wii games, but I haven't used it for that before. I think getting the controller set up is a whole nother song and dance. But if you want to get Dolphin on your computer, it's totally free. You can go to dolphin-emu.org to get a hold of it, and that's EMU as in emulator. Okay, so as I was saying, the bridge between these devices is called Steam Link, and we have a guide on Tom's Hardware that goes over everything you need to do to get it set up both on your Raspberry Pi and your computer and get them working together. But here's what it looks like in action. Once you have Steam Link set up on your Raspberry Pi, you can add Dolphin to Steam on your computer as another app. And when you load up Steam Link on your Raspberry Pi, Dolphin will appear in your library of games. And then it's just a matter of launching Dolphin and choosing the ROM that you want to play. And you can hook up your controller to, not hook up, but the controller is configured to Steam Link on the Raspberry Pi. I happen to have with me a Wavebird, which is the original wireless GameCube controller. And if you want that to work on your Raspberry Pi, you will need an adapter that converts the original GameCube controller port to USB. Your mileage may vary, but it's definitely possible to play GameCube on the Raspberry Pi. I would show you it working behind me right now, but I'm worried that we're going to run into some copyright issues, so I'm not going to load up any ROMs. I'll leave it up to you guys to get it working, and check out tomshardware.com to get started with Steam Link. So what do you guys think? Do you want to play GameCube on the Raspberry Pi?
Yeah.
Why not? We'll play everything on the Raspberry Pi, although it's really, I guess in this case, playing it on your PC and then projecting it onto the larger screen onto the TV, which is very useful. I should mention that we have a story going up probably this weekend on Tom's Hardware about comparing different methods of playing retro games. And we're comparing PC emulation versus Raspberry Pi emulation versus retro consoles versus the original consoles to see like which is the best. Our tester I don't think she tested any GameCube or Wii. It was primarily PS1, and Super NES, and Genesis that she was testing. And she generally found that obviously the PC was a little bit more powerful than the Pi for certain things that push the envelope. But emulating on the Pi is great because it's easy to hook up to your TV or put in a wonderful little arcade box. So
I did find something cool in my research. Now, the reason I chose to show off Steam Link is because it opens it up to 3D Plus users. But somebody supposedly managed to get Dolphin installed and running on a Raspberry Pi 4. It did not do that well. It depends on the game you want to play, of course. But I haven't tested that. Maybe possible.
Yeah. So one last thing I wanted to show before we go today was I want to talk a little bit about something actually Les brought up, which was using Neopixels. So Neopixels are, let me show really quick. Neopixels, actually I think Neopixel is the brand name of these from Adafruit, but you can actually buy these not from Adafruit. I think they're technically known as WS2812B lights. Is that correct, Les? I think.
Correct, yeah.
Right, WS2812B lights. So anyway, you may find them a little bit cheaper, although Adafruit makes some really nice ones. So you can buy them in many forms. You can buy them in rings, you can buy them in boards, and here they are in strips. And what's neat in strips is that you can cut them. So they're like some type of I don't know. It's really true of worms that if you cut them in half, you get 2 worms. I don't think that's actually true. But anyway, if it's true with this because you can cut these into pieces, and that each one of them will work independently, and you can daisy chain them too by running wires through them. So my son and I are still working on our very wiry robot here, which we're getting to work, and he wants to put some RGB lights on either side of it, and obviously the easiest way for us to do that was to take some of these and cut them. So I cut a piece off here, and I had to solder, and I have to admit my soldering wasn't great. It was a little bit of a pain to solder to these pads. Solder onto this group of 6 lights. And though some of the instructions I read said you need a separate power supply, I found that with the Pico that is just not true. It would actually light up all 144 lights on my strip with no problem. Here I have the 6 ones, and what you have here is it goes to the 3.3 volt and the ground, and in this case GP0, although it could be any GP that you want. And I'll show you that while it's easy to do this in CircuitPython, which is Adafruit's own version of MicroPython, you can also do this in regular MicroPython. So here I'm going to show you. Let me do a quick screen share, and you'll see my code. So here I have my code, and it's very, very simple. I'm using a library that I got that some kind person named, I think it's Blazar, created that works specifically for MicroPython. So normally there are things for Neopixel for CircuitPython, but here there's one for MicroPython, and you just need to copy this off of GitHub as off of Blazar's GitHub page, and then all you have to do, this works very similar to how it would in CircuitPython, is you import Neopixel, you set the number of pixels. In my case, I put 144 because my strip had that, but actually right now I only have 6. I think it's okay if you overshoot, just if you don't undershoot. And then you put the number of pixels, you create an object, which we're going to call pixels. With the Neopixel, you put the number of pixels.
Hey, it's GRB like Les's project.
And it's GRB. I wanted to point that out. I tried this with RGB, and it was all messed up until I made it GRB. I don't know why it's GRB, why it has to be GRB. Do you, Les?
No idea. I've come across Neopixels that are RGB and GRB format, and I've not been able to identify readily the difference. Now, when I buy them from AliExpress or Adafruit or eBay, wherever I get them from, it will stipulate that it is GRB or RGB format, but when I get them, I can't tell the difference. There is probably going to be some little dot on a chip somewhere that says there's a difference, and I've just not spotted it.
So this is the GP. I'm not sure why we actually have to have 2 zeros here, but the first one of these, I believe, is the pin number. And then if you want to do just one pixel and you want to set it, you just do the index of the pixel, which in this case could be 0 or 1 or up to 5, and then you put in parens the GRB. So if you want it to be green, the first number should be 255. So that will light up just one pixel, or if you want to light them all up, you do fill. So I have fill going here, so you'll see, ta-da, all blue. So there are rainbow effects that you can do with this and all of that, but I think this is a nice little start. If you want to put RGB lights onto a project using Neopixels, you can do it with MicroPython, you can do it with CircuitPython, you can do it with, I think, regular Python. It's really easy to do. So that was just a quick look at all of that. We have one more question that TrueLinky asked if your board is going to be open source.
So at the current state, it's not open source. The reason for this is simply, as I said, I'll be going for a crowdfunding campaign with it, and if this is successful, I want at least like half a year where I'm the one exclusively selling it, but especially if this crowdfunding campaign fails and not gets funded, I will release the design files to open source, because then there's no reason to keep those things a secret. Yeah, I'm looking into this, and I believe that sooner or later I will release it. Yeah.
Great. Well, thank you very much to Pascal and to everybody else who tune in to watch and listen. We are here every Tuesday at 7:30 p.m. British time, 2:30 p.m. Eastern, and we will see you on the Tom's Hardware podcast next week. Bye, everyone.